Simple harmonic motion. Next one is simple pendulum beta. Concept of simple pendulum. Okay, see here. This is your pendulum. This is your string to which a bob of mass m is attached. Okay, the center of this one is this one. The distance from this center to the point where it has been hanging. This is your length of your L. Okay, so L is nothing but what me for me? Length of the pendulum. Length of the simple pendulum. Okay. See, string is in the vertical direction. The bob is also, this is right now for me, bob of mass m. This is your string of length L. Okay. Tell me what all forces will be acting on this body beta. When it is in the rest position, the forces acting on the body is weight of the body mg. The tension in the string will be equal to your T. Okay. Now when I displace the body slightly, okay, like say for example, when I displace the body slightly from the mean position, this was the initial length. I'm displacing this body to this position. Okay, or I'm displacing the body toward this position. Okay, so this point is known as of your mean position. This one is known as of your extreme position. Okay, so the bob has gone from here. The center of mass is this one. This one is also same right now. Okay, that is making an angle of your theta. This one is also making an angle of your theta. Clear? Now tell me in extreme position, what will be the forces acting on the body? One is the weight of the body acting in the downward direction. That will be equal to your mg. Isn't it? Tension in the string will be no doubt. This will be equal to your T. Okay. As the body has been going in this direction right now for me, if I resolve the forces acting on the body, one is along the string like this, and one is back the string like this. Okay. If this is the string here, this is your angle theta. So if I resolve it, this value will be equal to your mg into cos theta, and this value will be equal to your mg into sin theta. Mg into sin theta is a restoring force which is bringing the body back to the mean position. Okay. Now in the extreme position, if I write the equation for this one, net force from Newton's second law, F net must be equal to mass into your acceleration. Net force acting on the body is equals to your F net must be equal to mass into your acceleration. Isn't it? Now tell me what all forces are acting in the extreme position better. One is right now for me, T towards the tension of the string, T minus opposite to T, there is one more force that is nothing but mg into cos theta. That must be balancing your m into, this is your centripetal acceleration, so it is v square divided by r. R is nothing but length of the string, right? Am I clear?
Yes, sir.
So net force in the extreme position is how much? T minus mg cos theta is equals to m into v square divided by your L. Now let us try to do it by the force method. I'm simplifying this one by the force method. First one is your force method. Now tell me what is the force which is making the body to come back? It is mg cos theta, sorry, mg sin theta. So F is equals to your minus of your mg into your sin theta. Isn't it? Now see here there is no force right now for mg sin theta is only unbalanced force. T and T is been balanced by mg cos theta, but mg sin theta is not balanced by any force. So that force is called as what? Restoring force. This one is right now for me what? Restoring force. So restoring force on the pendulum is F is equals to minus of mg into your sine theta. For small oscillations, beta, every time you remember, for small oscillations, SHM is seen for the small oscillations only, beta. Theta is very small. Theta is very small, like 1 into 10 to the power of minus 6, 0.1, 0.2, something like that. So in that case, sine theta will be approximated to your theta, isn't it? So F value will be equal to minus of your mg into sine theta will be represented by your theta. Now from Newton's second law, F is equals to m into your A, that is equals to minus of mg into your theta, m and m gets cancelled. So acceleration will be equal to minus of g into your theta. Now compare this one with your SHM beta. Compare this one with your SHM. Now see here, as we know that theta will be equal to, from the figure, arc length will be equal to, theta is equals to arc length divided by radius. Arc length divided by radius. Okay. So for arc length, I'm giving some distance. Let's say, for example, it has been gone from here to here, isn't it? This is your arc length. This is your x, and this is your length L. Okay. So sine theta will be equal to how much for me? Theta is equal to arc length. Arc length is equal to x divided by your L. So I can write that value here. A is equals to minus of g into theta is equals to x divided by L. Am I clear?
Yes, sir.
So acceleration is equals to right now for me. A is equals to minus of g into your x. That means A is equals to minus g divided by L into your x. G by L is a constant. Compare it with your compare it with SHM equation. A is equals to minus of omega square into x. So we'll see that omega square is equals to how much for me? G divided by L. So from this one, I'm getting omega is equals to under root of G divided by L. So once I know the value of your omega, I can calculate the time period for this one. So time period will be equal to how much for me now? T is equals to 2 pi divided by omega. That is equals to 2 pi divided by L is equals to under root of G divided by L. So this is your 2 pi. This is under root of your L divided by G. Am I clear? So time period of your simple pendulum is given by the formula T is equals to 2 pi L divided by G. So this is your time period. Am I clear?
Yes, sir.
So the time period of a simple pendulum for small oscillations, for very small oscillations, it is given by the formula T is equals to your 2 pi under root of your L divided by your G. See, whenever we need to calculate the time period, we need to displace the body from the mean position beta. Isn't it? So whenever you displace the body from the mean position, and at the mean position, if you write all the forces like force equations and simplify it with your basic given equation of SHM, we will be getting the time periods are angular frequencies. Am I clear?
Yes.
This was by what method? Force method. This one was by your force method. Now, let us try to derive the same thing by your torque method. Next one is your torque method. For all the methods, one thing is very clear. We need to displace the body from the mean position. Like say, for example, this was your ceiling and this one was your mean position. Now the simple pendulum is somewhere here right now, making an angle of your theta. Okay. Tell me what all forces will be acting on this body right now. For this is the length of the string. Tension in the string will be equal to your this one T. This one is also T. Weight of the body will be equal to your mg in the downward direction because mass of the string is right now for mere m. Isn't it? If this is making an angle theta, this one is also theta, alternate. Okay. Now tell me what is the restoring force acting on it? Restoring force. Isn't it? As it is in a circular path, force is represented by torque. So torque will be equal to force into perpendicular distance. Okay, this is the length L. If I resolve the length L into components beta, so this value will become for me L cos theta, and this value will become for me L into your sin theta. So torque will be equal to force into perpendicular distance, isn't it? So this is your minus of your force is your mg into perpendicular distance is what for me? L into sin theta, isn't it? So torque will be equal to tau is equals to minus mg into L into your sin theta is the torque acting on the body. For small oscillations, again, for small oscillations, for small oscillations, sin theta will be approximated to theta, isn't it? So tau value will be equal to minus of mg into L into your theta. Now from rotational mechanics, you know the torque is equals to I into your alpha. I is moment of inertia minus of mg into L into your theta, isn't it? Now from this one, angular acceleration alpha will be equal to minus mg into L divided by I into your theta. Okay. So now if I simplify this one, alpha is equals to minus, this is totally a constant, mg into L divided by your I into your theta. Okay. In rotation mechanics, you know that A will be equal to your alpha. So comparing it with your angular SHM, compare it with angular SHM, angular SHM. So what is the linear acceleration beta? We know the formula A is equals to minus of omega square into x. Now in rotation, A is represented by alpha, that is equals to minus. This is same again omega square, and x is represented by theta. This is your angular SHM acceleration. Alpha is equals to minus of your omega square into your theta. What is the value of omega square I'm getting? Omega square is equals to mg into L divided by moment of inertia. So from this one, omega is equals to how much for me? Under root of your mg into L divided by moment of inertia. This is your angular frequency of your SHM. Okay. Now use the time period formula. T will be equal to how much for me? T is equals to 2 pi divided by omega. That is equals to 2 pi divided by omega is equals to under root of your mg into L divided by I. So if I simplify this relation, the time period I'm getting here is right now for me, T is equals to, capital T is equals to 2 pi under root of your, this is your I divided by mg into your L in terms of moment of inertia. So T is equals to your 2 pi under root of your I divided by mg into L, where L is the distance between the point of suspension and center of gravity beta. L is equals to your distance between point of suspension to center of gravity. Okay.
Yes, sir.
What is the moment of inertia for a point mass beta? For point mass, moment of inertia will be equal to your m into your L square. So therefore, time period will become for me T is equals to 2 pi under root of your m into L square divided by mg into your L. This L, this square will get cancelled. So if I simplify it, I'm getting the time period T is equals to your 2 pi under root of your L divided by G. So this is the time period by the torque method. Am I clear?
Clear, sir.
So for point mass, the moment of inertia I'm taking here out, I is equals to m into L square, isn't it? Now tell me if Bob is a sphere of radius r, then moment of inertia for this one will be equal to how much? But I is equals to, from point of suspension, I is equals to ICM plus of your m into your L square. Moment of inertia for a solid sphere will be equal to how much? If nothing is being told, it should be taken as solid. It is 2 by 5 into m into your L square plus of your m into your L square. Am I clear? So 2 by 5 plus 1 will be equal to how much? 2 by 5 plus 1 into m into your L square.
7 by 5 ml square.
How much?
7 by 5 ml square.
The moment of inertia. So what will be the time period right now? T is equals to 2 pi under root of your, what is the value of moment time period in terms of moment of inertia? I divided by mg into your L. I value is how much for me? 7 divided by 5 into m L square divided by, this is your how much for me? Mg into your L. Isn't it?
Yes, sir.
Now in this one, what I can cancel? This L, this square, this M will get cancelled. So time period is coming for me how much? T is equals to your 2 pi under root of your 7 into your L divided by your 5 times of your G. This will be the time period. Okay. So in general, I can write time period will be equal to T is equals to 2 pi under root of your, isn't it? This is the moment of inertia about the center of mass plus m into your L square divided by your mg into your L. So this will be the moment of inertia. In terms of moment of inertia, the time period. So T value is equals to how much for me? T value is equals to 2 pi under root of your ICOM plus m into L square divided by mg into. Am I clear?
Yes, sir.
Sphere, what is the moment of inertia? 2 by 3 mr square. If rod is given, ml squared by 3 or ml squared by 12. Like that, we can go and use the relations. So time period for a simple pendulum is given by the formula T is equals to 2 pi under root of your L divided by G. Am I clear?
Yes, sir.
चलो अब इसका एप्लीकेशन देखो एक बार जल्दी से. Now tell me, time period will depend upon what beta? Length in G for a point mass. Time period of simple pendulum. Time period of your simple pendulum depends on L and G. The time period was T is equals to 2 pi under root of your L divided by G. So this is your time period. T is equals to 2 pi under root of your L divided by G. Am I clear?
Yes, sir.
Length is decreasing or changing, a moment of inertia length is increasing or decreasing. Accordingly, it will be behaving. Like say first one, T is directly proportional to root of L, I can write when G is constant, isn't it? So I can write here T2 divided by T1 is equals to under root of your L2 divided by L1. In terms of percentage, if I'm writing T2 divided by T1 minus of 1 into your 100 will be equal to your under root of your L2 divided by L1 minus of your 1 into your 100. Okay. Now see, for small percentage changes, we can use error approximation. Delta T divided by T into your 100 will be equal to half into delta L divided by L into 100. Like the percentage changes are lesser than 10%, like 2%, 3%, 4% for that one. If it is greater than that one, then you can directly use the standard formula T2 divided by T1, isn't it? Like say example, if I'm giving you, if length is increased by 21%, then delta T divided by T into 100 is equals to how much? Now see here percentage is greater than 10, then don't use the formula of the delta T by T into 100. Use this one, T2 divided by your T1. If it is greater than 10%, you use this formula to simplify the problems. Okay? Sure. Now
Yes, sir.
T2 minus of T1 divided by T1 into your 100 will be equal to This is under root of your L2 divided by L1 minus of your 1 into your 100. Am I clear?
Yes, sir.
So now, what is the length of L2 beta? If L1 is 100%, okay, if initial length L1 is equals to 100%, L2 will be equal to how much for me? 100 plus 21, it is equals to 121%, isn't it? So it is your 121 divided by 100 minus 1 into your 100. See how much I'm getting this one. Under root of 121 divided by your 100. Root 121 is how much?
11.
Okay, it is 11 divided by root 100, 10.
10.
1 into your 100.
Yes, sir.
So now see how much I'm getting this one.
So 1 by 10 into 100.
11 minus 10 divided by 10. Can I write like this?
Yes.
11 minus 10 is 1. 1 divided by 10 into your 100. This one
Yes.
cancel. So how much it is? 10%.
10%.
Am I clear?
Yes, sir.
Percentage problems we can do like it right now. Now see here for this one. So t, when g is constant, time period is directly proportional to your root of your L. Now see, tell me what will be the graph of this one beta? L versus t graph. L versus your t graph and L versus your capital T graph. Okay. From this one, I can get the length L is equals to how much work? G into T square divided by 4 pi time period formula. T is equals to 2 pi under root of, from this formula, T is equals to 2 pi under root of your L divided by G. Square on both the sides. T square is equals to 4 pi square. This one is your pi square. Okay. L divided by G. So L is equals to G into T square. So that means length is directly proportional to your T square. Length is directly proportional to your T square. So what will be the graph if I'm taking right now here? This is your graph. On this one, I'm taking T square. Okay. On x-axis, I'm taking the length L. So what will be the graph? It will be a straight line. Make an angle of your theta. And what will be the slope? Slope will be equal to your tan theta. Tan theta is nothing but equal to your m. M will be equal to your 4 into pi square divided by your g. Am I clear?
Yes, sir.
Isn't it? Because on y-axis I took the t square, na? So if I write this equation like this, t square is equals to L into 4 into pi square divided by g. Isn't it? So comparing it with your y is equals to m into your x. On y-axis, I took t square. On x-axis, I'm taking the length, and m will be the slope. That is right now for me 4 pi square divided by g. Okay. The same way, time period versus your t, our length condition, L versus your t. This is your time t. This is your length L. It will be what? Rectangular hyperbola like this. Sorry, parabola in the upward direction. Okay. And now see, t is equals to 1 second. T is equals to 1 second. L versus T and L versus T graph. both will coincide. Try to remember. Okay, I'm considering at what time? Graph, consider at t is equals to 1 second. So t is equals to 1 second, L versus t, and L is equals to t square. Only at 1 second, this is possible. For other conditions, it will be changing. So I got the two graphs right now for me. One is L versus t graph and L versus your t graph. Am I clear? This is like y is equals to k into your x square. This one is very important. Bit. Time period is directly proportional to what? Length. T is directly proportional to root of your L. So from this I can write time period of longer length divided by time period of shorter length will be equal to, this will be equal to your length of your, or number of oscillations I can say. This is your under root of your length of your longer one divided by length of your shorter one, or frequency of smaller oscillation divided by your frequency of larger oscillation will be equal to under root of your length of longer one divided by length of your short one. So this will be the relation. Am I clear?
Yes, sir.
This is very important formula we get. We get a lot of problems based on this one. Let me give you one small example for this one. Yeah. Let's say length of the shorter length of the pendulum is 100 centimeter and length of the longer pendulum is 121 centimeter. Okay. They started oscillations. They started oscillations with same phase, with the same phase and amplitude. And amplitude is same. Okay. Then after how many oscillations? After how many oscillations of shorter pendulum will they be in same phase? Okay. First length is given 100, another length is given as of your 121. They started oscillation with the same phase and amplitude is also same. Then after how many oscillations of shorter pendulum will again they will be in the same phase is asking. You know that oscillation of the smaller divided by oscillation of larger will be equal to your under root of your length of your longer divided by length of your shorter. That is equals to under root of your 121 divided by 100. That is equals to 11 divided by 10, isn't it? That will be equal to 22 divided by 20. That will be equal to 44 divided by 40. Go on like that one. First oscillation will be at 11 divided by 10. The next one again at 22 divided by 20 multiplied by 2. Then again at 44 divided by 40. In these cases, they will be same. So if I take the first condition, NS divided by NL will be equal to 11 divided by 10. Isn't it? So number of the shorter pendulum, 10 times of your shorter pendulum will be balancing with your 11 times of the number of oscillations of your larger one. Isn't it? By the time the longer one makes the 11 oscillations, that will be equal to your 10 oscillations of the smaller one. Like that. Or 22 divided by 20 or 44 divided by 40. Go on like that. Then see the question carefully. Shorter length is given, longer length is given, and is telling that after how many oscillations of the shorter pendulum will they be in the same phase. After 10 oscillations of the smaller pendulum, it will be in the same phase with your longer one. So 10 ns will be equal to 11 ns. How I got 22 divided by 20 beta? I just multiplied by 11 by 2 and 10 by 2, divided and multiplied by 2. Got it? Sure. Next one. For a given length, L. If I write small l or capital L, it is one and the same bit. For a given length, I'm talking about case number 1. If it is in a lift, okay, so this is your lift, and there is a simple pendulum here of length L. Lift is stationary beta. Lift is stationary. So there is no acceleration. So at that time, the time period will be T naught is equals to 2 pi under root of your L divided by G. So T is inversely proportional to root of your G. So from this one, I can write T2 divided by T1 will be equal to under root of your G1 divided by G2, inversely proportional. Okay. Second one. If the lift is moving in the upward direction or accelerating in the upward direction, this is your simple pendulum which is being hanging to the ceiling of this one. Here is your ceiling. This is your ceiling. So length of this one is L and it is moving upward with the acceleration A. So pseudo force will be acting on this one body beta. Weight of the body is your mg in the downward direction. Now in this case, if I'm talking about tension will be in the upward direction and pseudo force will be acting on the body as it is an accelerating frame in the downward direction. So tension T is being balancing by the formula. T is equals to your how much? T is balancing your mg plus m into your A. This you already studied in the Newton's laws beta. M into G plus A is your tension. What will be the acceleration? M into your net acceleration, A net will be equal to your M into G plus A. So this M will get cancelled. So net acceleration will be equal to G plus of your A. Am I clear? That means the time period formula will become how much for me? T is equals to 2 pi under root of your L divided by net acceleration is G plus A. This will be the formula. Lesser than your time period of T naught. Am I clear? So when it is accelerating in the upward direction, the tension in the string is being given. Sorry, the time period of the string is given by the formula T is equals to 2 pi under root of your L divided by G. Here this one is your tension beta. And this T is your time period. Be careful of that. Okay. Now if the lift is accelerating in the downward direction, but this is your lift. And this is your string, simple pendulum of length L. And the lift is moving in the downward direction. Forces acting on the body mg, tension in the string up. Now pseudo force is in the upward direction, m into your A. So in that case, G effective will be equal to G minus A bit. So time period formula is T is equals to 2 pi under root of L divided by G effective. That means the time period will become for me T is equals to 2 pi under root of your L divided by G minus A. So when it was moving up, G plus A. When it is moving in the down, G minus of your A. Am I clear? Sure. Fourth. If the truck is moving in the forward direction, like say this is your truck and there is a simple pendulum attached to this one. Okay. And this truck started accelerating in the front direction. Okay. This is your truck, this is your road. So the moment it has been accelerated, this bob will be moving in the backward direction beta, making some angle theta. Now tell me what all forces will be acting in this position. One is your mg in the downward direction and pseudo force in the this direction. net will be equal to your M into G effective in this direction, which is balancing the tension in the string. Okay. So then G effective will be equal to how much parameter? G effective will be equal to your under root of your G square plus of your A square. Because angle between these two forces is how much? 90 degrees. Isn't it? So like say F is equals to F net is equals to under root of your mg whole square plus m into your A whole square. Parallelogram law of addition. M into G effective will be equal to, this is under root of your, this value will be equal to how much for me? M square G square plus M square A square. So from this one, if I take M square out, so it will be M under root of your G square plus of your A square. It is your M into G effective. This M will get cancelled. So G effective will be equal to how much? G effective is equals to under root of your G square plus of your A square. This is your G effective for the truck. So that is the reason I took that G effective is equals to this much. So time period will be T is equals to 2 pi under root of your L divided by G effective. G effective is here G square plus of your A square. This is your time period. T is equals to 2 pi under root of your L under divided by under root of your G square plus of your A square. Am I clear? So for a given length, I told you that time period will be directly proportional to length L, isn't it? So when G is constant right now, T is inversely proportional to your G. So from that one, I got T2 divided by T1 is equals to your under root of your G1 divided by G2. If the lift is moving in upward direction, then time period is T is equals to 2 pi under root of your G plus A, which will be lesser than the time period when the lift is at the rest condition. When it is moving in the downward direction, the time period is T is equals to 2 pi under root of your L divided by G minus A. When the truck or when a bus is accelerating in the front direction, G effective is equals to under root of G square plus A square. I have told you how we got this one. So time period will be calculated with the formula T is equals to 2 pi under root of your L divided by under root of G square plus of your A square. Am I clear?
Yes, sir.
As you have completed gravitation beta, with respect to gravitations also we can write the time period because G is inversely proportional to the depth. So I'll write here G varies with different factors. What are the different factors, beta? One is with respect to height, with respect to depth, with your rotation. The G value has been going on changing now, isn't it? So first one, if I take it with depth, if I'm writing with depth, what is the value of the G beta? G with your depth will be equal to G into 1 minus D divided by radius of the earth. And radius of the earth is how much work? 6,400 kilometers. Am I clear? So time period is inversely proportional to under root of G with respect to height. So with respect to depth, sorry. This is with respect to depth. Okay. Now with respect to height beta, with altitude, when the body is taken to certain height, then G with respect to height will be equal to G into 1 minus of your 2h divided by R. R, we also write this one as G with respect to height is equals to your G into this one is R divided by R plus of your H whole square. Okay, this formula to be used when H is much lesser than capital R. Am I clear? And we also know the relation in the gravitation beta. Small g is equals to capital G capital M divided by your R square. Isn't it? That means G value is directly proportional to the mass and radius R square. That means as the planet is being changing, G value is also changing. So at that time I can write G in terms of volume and density and simplified. You know the formula, G value will be equal to 4 by 3 pi into rho into G into your capital R. So G in terms of your density is given by this formula. That means G is directly proportional to your capital R and as well as of your density. In terms of density, if it is given, we can write these conditions. Okay. That I'll try to do it in problems better, how to use this all conditions, but try to revise it right now here. So when a simple pendulum is taken to a certain depth, then in the place of G, you can substitute this value. When it is taken to a certain height, then G value, you can substitute this one when H is very, very greater or comparable to radius of Earth. If it is very small, you can use it this one. Okay. Now you know that right now for the given conditions, small g is equals to capital M divided by r square. Mass of the earth is spherical in shape, so mass is equals to volume into density. Volume is 4 by 3 pi into r cube. So for simplify it, we are getting the formula small g is equals to 4 by 3 pi rho g into r. That means g is directly proportional to capital R divided by g. When time period for problems are being given, you can use like this: t1 by t2 is equals to under root of your g2 divided by g1. That is equals to under root of your r1 rho 1 divided by your r2 into rho 2. Like say in a problem, he has given me the radius of the sphere and density of that body. Then calculate the ratio of time period. Then I can use this formula. T1 by T2 is equals to under root of G2 by G1. That is equals to under root of R1 rho 1 divided by R2 rho 2. Rho is nothing but what? Density of object, whatever the object he has given right now. Am I clear?
Yes, sir.
These are all related to your gravitation relations with. Sure. Next one is about your seconds pendulum. Seconds pendulum. What is a seconds pendulum? A pendulum whose time period is equals to 2 seconds. A simple pendulum, a pendulum whose time period is equals to 2 seconds is called as of your seconds pendulum. So time period will be t is equals to 2 pi under root of your L divided by your G. Now t value is how much for me? 2. So what is the length of the seconds pendulum? Length of seconds pendulum. How much it will be, Vida? L will be equal to G divided by pi square. Isn't it? Got it? L is equals to G divided by pi square. From this equation, better. Square on both the side. 2 square is 4. That is equals to 4 into pi. This is your L and this is divided by your G. This 4 will get cancelled. So L value will be equal to how much for G divided by pi square. Okay. On earth, better. On the earth, the value length of your simple pendulum on the earth will be equal to G divided by pi square. G value is 10 and approximately pi square value is also 10 beta. So it will be equal to 1 meter. What should be the length of the simple pendulum on the surface of the earth? It will be 1 meter. Now if I'm talking about on the moon, length of the simple pendulum on the moon will be equal to G on the moon divided by pi square. You know that G on the moon is equals to how much for me? 1 by 6 times of the G on your earth. So it is 1 by 6 times of your G into your pi square. So it will be equal to approximately 1 by 6 meters. Because G by pi square value is already how much for me? 1 meter. Isn't it? Now if I'm talking about change in length of seconds pendulum. Length of your seconds pendulum. How do you write this change? L2 minus of your L1 is equals to G2 minus of your G1 divided by this value will be a constant. So change in the length of the seconds pendulum can be calculated by the formula L2 minus of your L1 is equals to your G2 minus G1 divided by pi square. Okay. One more and very important formula, but I'm not deriving it, but just try to remember it for doing the numericals. Time period of your very long pendulum. Time period of long pendulum. What is the time period of your long pendulum? बेटा formula याद है किसी को? time period formula will be equal to, if the length of the pendulum is very, very large compared to the radius of the earth, then time period is given by the formula T is equals to your 2 pi. This is your under root of your L divided by G. In the place of L, it is your R divided by your G into 1 plus R divided by L. So this is your time period. If length is infinitely long, then what will be the time period? Length will become infinity, isn't it? Let derive it better. Okay, I'll divide it later. Just remember the formula. See, for pendulum of infinite length, So when L is equals to infinity, all right, sir. Anything divided by infinity will be equal to how much for me? 0. Then time period will become how much for me? T is equals to 2 pi under root of your R divided by G. Okay. So here length is equals to how much for me? The radius of the earth. And you know what is the radius of the earth? 6,400 kilometers. Okay. So if I simplify that value, keeping the value of the G and everything, we'll be getting this one as approximately 84.6 minutes will be the time period for the infinitely long length. Okay. Now if the length is equal to R, length is equals to your capital R, then time period will become for me T is equals to 2 pi under root of your, this value will become for me R divided by 2G. That means I can write this one as of your 2 pi under root of your R divided by G multiplied by 1 by root 2. You already know that 2 pi under root of R by G is 84.6 seconds. So it is 84.6 minutes divided by root 2. If I simplify this one, approximately I'll be getting this one as equals to your 60 minutes. That will be equal to 1 hour. These are the standard values which should be committed to your memory beta. Okay. For infinitely long length of the time period, what is the time period? So time period is given by the formula T is equals to your 2 pi under root of your R divided by G, and value of this one is 84.6 minutes. By using the formula of radius of Earth 6,400 kilometers, convert the kilometers into the meters because G value will be in the meters. If L is equals to R, then time period is 2 pi under root of your R divided by 2G. Simplifying it, we are getting 60 minutes, or it will be equal to 1 hour. Am I clear? इसके एप्लीकेशंस और बहुत सारे है बेटा, ये तो मैंने अभी बेसिक बेसिक ही करवाया है. इसका डेरिवेशन भी कर सकते हैं, बट इट इज ऑफ नो यूज. इफ यू नीड इट, यू लेट मी नो, आई विल ट्राई टू डिराइव. बट इतना खास तो जरूरत नहीं है, बट ओनली थिंग इज मैथमेटिकल एप्लीकेशन लगा के करना है. फाइनली तो आपको करने के बाद भी डेरिवेशन याद ही रखना है. दैट इज द रीजन आई एम डायरेक्टली राइटिंग दिस एप्लीकेशन. टाइम पीरियड फॉर ए लॉन्ग पेंडुलम अगर अभी भी पूछ रहा है तो यूज द फॉर्मूला P is equals to 2 pi under root of capital R divided by G into 1 plus of your R by L. Okay. इसको डायग्राम बताता हूँ. अगर ये मान के चलो, दिस इज योर अर्थ. Okay, and this is the radius of the earth, capital R. And you're taking the simple pendulum somewhere here from the surface of the earth. Very long simple pendulum, like say you've gone 100 kilometers. This is the length of the simple pendulum on the surface of the earth. Now you displace it to the small position somewhere here right now. This is making an angle of your theta. If I try to draw the distance for this one like this will be the distance right now for me, arc length. So almost all I'm taking straight like an X. Now this is making an angle of your right now for me phi. The line joining the bob and as well as this given condition. Okay, so this is your earth. Tell me what all forces will be acting on a simple pendulum better. One is the weight of the simple pendulum. Weight of the simple pendulum is acting in the downward direction. So if I take one of its component, so this will be the restoring force acting on this one. So always mg is acting towards the center of earth. And if it is making an angle of your phi, this angle will be equal to theta plus of your phi. So this will be equal to mg into cos of your theta plus of your phi will be its component. Done. This is the length of the pendulum, that is nothing but equal to your L. And restoring force by which the body is been coming in the backward direction. So if I draw a restoring force here, if this mg is in the downward direction, this is a restoring force. This will be equal to your mg into your sine theta plus of your phi. I use the restoring force concept and try to derive it better. What is the restoring force acting on it? I'm roughly doing it. Restoring force. Derivation to जरूरत नहीं है, just for your understanding. F value will be equal to minus of mg into your sine theta plus of your phi. For small angles, if I'm talking about, for small angles, I can write F is equals to MA, that is equals to minus of your mg into theta plus of your phi. M and M will get cancelled. Acceleration A is equals to minus of G into, from the problem, theta will be equal to x divided by L and phi will be equal to your x divided by capital R, isn't it? So comparing with the standard equation, so from here I'll be getting the angular frequency or angular velocity. Omega is equals to under root of your, this is your G into your, this value will be equal to how much for me? If I'm taking x to be a common right now for me, this will be equal to 1 by L plus of your 1 by R. This is your omega. Once I know the value of omega, I can calculate the time period. Okay, that is the way which I have taken here right now. T is equals to 2 pi by omega. T is equals to 2 pi by your omega. Got it now? Let's see, in this one x is common बेटा, तो यहाँ पर ये कितना बन जाएगा? A is equals to minus g into 1 by L plus of your 1 by R into x. Comparing with A is equals to minus of omega square into x. So omega value is equals to this much. जरूरत नहीं है derivation, but just try to remember the formula. T is equals to 2 pi under root of R divided by G into 1 plus of your capital R divided by your L bar. Am I clear? Derivations थोड़े lengthy हो गए बेटा, but we need to do that one because SHM बड़ा chapter है, फिर भी मैं 1 week में complete करने के conditions में थोड़ी थोड़ी चीजें मैंने directly लिखे हुए हैं, कुछ पार्ट समझ में नहीं आ रहा है तो you let me know, I'll try to help you out. Yesterday कुलसुम आपने ये पूछा था कि कैसा आया हुआ था, आप लोग का मैकेनिक्स होगा ना, फ्लूइड मैकेनिक्स, isn't it? In this one, the fourth case of your simple pendulum. मेरे पेपर स्टक हो रहा है बल्कि मैंने सेकंड में तो लिया बेटा, सेकंड पेपर. हाँ, केस नंबर 5 देखो बेटा. इसके अंदर I told you that when the body is half immersed or some part is immersed in the liquid, give a small oscillation and leave it. It will try to make to and fro motion. In the to and fro motion, what are the forces acting on the body? One is the weight of the body mg in the downward direction, buoyancy force in the upward direction, and spring force in the upward direction. Spring force का formula k into x naught. Buoyancy force also in upward direction, that is balancing the weight of the body mg. So if I bring this, buoyancy force will be equal to your outward net force. F net is equals to your restoring force will be equal to your how much for me? Newton second law लगा रहे हैं अपन basically. Okay. So displace the body by small displacement at a time will be equal to your how much for me? This is k into x plus x naught plus of your buoyancy force, isn't it? When you displace it, the buoyancy force is also changing. So it is right now for me Fb dash. Now see this one, kx plus of your Fb will be equal to mg. That means this mg, this Fb and this kx will be getting cancelled, isn't it? So I'm getting F is equals to minus of kx plus of your buoyancy force. अगर ये पूरा नहीं करना है आपको डायरेक्टली, यू कैन राइट फ्रॉम दिस स्टेप आल्सो. हम लोग डायरेक्टली यहां से भी कर सकते हो. F net will be equal to, I'm drawing here right. So F net will be equal to mg minus buoyancy force right now acting on the body. Buoyancy force is acting in which direction, beta? Upward direction. So this buoyancy force is balancing given condition. So minus of your buoyancy force. Okay. In equilibrium, this mg will be equal to your spring force, isn't it? So displace the body at the extreme position. At extreme position, mg will be equal to k into x minus, I'm taking it as of your common. This will be plus buoyancy force. This is your F net. Because you need to displace the body now. In displaced position, weight of the body mg is balancing this relation k into your x. Is it? And buoyancy is also acting in the upward direction. Okay. So F net will be equal to your mg minus buoyancy force. And in extreme position, this buoyancy force is balancing your spring force. That is the reason I took mg is equals to k into x. So if I take minus out, it is minus of kx plus of your buoyancy force. In buoyancy force formula, you already know it. Volume mass density of liquid into g. Volume is equals to area into your x. So if I simplify it, F net is equals to your m into your a. We'll be getting the accelerations and as well as of your omega. So from this one, you can calculate the time periods. For it, we are having a lot of applications of this one better. Simple pendulum in the liquids, YouTube in the V shape, that all we'll try to do in the next section of your classes. Okay. समझ में आया? फिर एक बार डिराइव करके बताओ. कल क्लास रहेगी नहीं रहेगी, कल आई इन्फॉर्म यू बेटा, बिकॉज आई नीड टू डू द प्रॉब्लम्स इन एसएचएम. हम लोग तो कॉन्सेप्ट तो करते जा रहे हैं, प्रॉब्लम्स का एप्लीकेशन नहीं हुआ. सो विल ट्राई टू डू सम प्रॉब्लम्स एप्लीकेशंस इन द टुमारो सेशन. कल संडे है. आई डोंट नो इफ आई गेट सम टाइम, आई विल ट्राई टू टेक्स्ट यू ऑन द ग्रुप. Just see it out. We'll try to do some standard questions and applications of this one in the tomorrow session of a class. और टाइम पीरियड के भी और कुछ एप्लीकेशन है, if it is possible I'll try to do it and complete it in the tomorrow section. ठीक है?
Yes, sir.
बाय बेटा.